The birth of a new server is a complex process, as you might imagine, and requires a large and talented group of engineers and support people. There are many steps from concept to product manufacturing, and they often take place in parallel to minimize the new server's time to market. Compaq's technology leadership is a direct result of the innovation and extensive testing that occurs during these steps. So let's highlight some of them as we follow a new server product from its initial stages through final production. From the beginning, many factors influence the design of a new server, including changing customer needs, new technologies, and emerging standards. A new server concept results as Compaq product marketing and design teams attempt to balance customer needs and the technology that can be delivered against the cost and schedule risks involved in bringing the product to market. Many technologies that customers appreciate in today's servers were pioneered by Compaq. Creating leading-edge products sometimes requires that we create our own chipsets because the desired technology is not yet available in the market. Using an internal design allows Compaq to focus more on customer value than an outside vendor could. It also enables us to drive new standards for the industry with innovations such as PCIX, hot plug PCI, and server management features. And that gives Compaq the opportunity to be first to market with those standards, helping to proliferate them throughout the industry. Incorporating the design into a chipset takes the form of creating application-specific integrated circuits, or ASICs. Few companies are able to invest the resources and engineering talent to build these specialized chips, but Compaq considers it an important way to build technology leadership. Compaq is recognized as an industry leader, and one indication of that is the intellectual property created through these design and development efforts, which has led to an enviable record in patent awards. The first step in the ASIC design process is defining the architecture. This requires interaction between numerous groups and can sometimes take months to finish. When the definition is completed, ASIC engineers use a specialized programming language called Verilog to write a program that models the behavior of the device. The model is then plugged into a software model of an entire computer system for detailed testing and verification. Next, another program creates a physical description of the chip from the model. Engineers then analyze the placement of these physical components to optimize performance and enhance timing margins. Finally, the device is fabricated, and the finished part is installed on a prototype circuit board. The ASIC process is a massive effort, but the returns on this investment are market-leading products and industry-leading technology. While the server is in the electrical design phase, the mechanical design for it is being evaluated. Mechanical enclosures for industry-standard servers are also developed internally at Compaq. And that allows us to create innovative designs that enable new technologies, such as hot plug PCI cards and hot plug fans. Creating our own designs also gives us better control over the primary mechanical challenges that face every new server design. First, the structure must have sufficient mechanical strength and integrity to be able to arrive at the customer's site intact and fully operational. Second, airflow and cooling must be designed so that thermal issues don't compromise a server's reliability or availability. Mechanical mock-ups and thermal simulations permit careful analysis of these parameters. To help meet strict electromagnetic emission standards, special seals are used to minimize leakage on parts that can move. Once the preliminary analysis is done, prototypes are created. Prototyping is often a slow and expensive process, especially for the plastic parts that make up 30% of a typical server design. To dramatically speed this process, Compaq installed a dedicated plastic prototyping machine that can create a plastic part from the CAD design files in just a few hours. This greatly reduces the time needed to create samples of parts. and allows Compaq engineers to test the functionality of their designs very quickly. This capability, combined with other state-of-the-art design tools, allows Compaq engineers to create innovative, thoroughly tested mechanical designs in a very short time. While the mechanical design is in progress, printed circuit boards to support the various electrical components of the new server are also being created. Printed circuit board design begins by creating a schematic diagram and then translating that into a circuit board layout. Testing and validation are important aspects throughout our design process. The computer-aided engineering team performs substantial signal integrity analysis on the design even at this early stage. Industry-standard servers are based on Intel microprocessors, so Compaq engineers work closely with Intel to ensure compatibility in our designs. Next, a small number of boards are built so that basic functional testing of the design can begin. These boards are used to verify subsystem functionality and basic signal integrity. This is also the first time the board is installed into a chassis, so serviceability and manufacturability are reviewed at this stage. Once the design is proven in the prototypes, we're ready to start product validation. And the first step is to make a preliminary production run of the product. The units are built in a way that simulates factory methods. Any issues that arise in the process are carefully documented so they can be corrected before the design actually goes to the factory. The assembled units first run through basic factory diagnostics. Any failures are diagnosed to the subassembly level. The subassembly is then replaced, and the unit is put back into test. The failed subassemblies are returned to the design team so they can determine the root cause of the failure. Testing and burn-in for the units includes 48 to 96 hours in a thermal chamber, where the temperature is cycled from 50 degrees to over 90 degrees Fahrenheit and back again 3 times a day. The units continue to run diagnostics and undergo power cycling during this time to simulate the potential stresses of a customer site. This process is almost entirely automated. As many as 400 units can be in thermal testing at the same time. The entire build experience for the new design is documented to help determine whether the product is ready for manufacturing. Any failures or issues are quickly fed back to the design team so they can make changes as needed. When the units have completed the process, they are delivered to other Compaq labs for even more rigorous testing. In one such lab, highly accelerated life testing is performed. Here, units are subjected to thermal and vibrational stresses well beyond expected normal usage to induce failures and uncover design weaknesses. In this process, the unit is stepped through various thermal levels, starting at room temperature, moving down to -60 degrees Celsius, and then up to 90 degrees Celsius. After thermal stressing, the unit is subjected to increasing vibration levels. When a failure does occur, the unit is removed from the chamber, and the root cause is identified. Then the unit is repaired and returned to the chamber to continue testing. When the test cycle is complete, all failure information is relayed back to the design team. This improves the robustness of the unit at a basic design level. A very similar process is employed during the manufacturing verification stage of a new product, but this time the stresses are kept well below destructive limits. This testing, called a highly accelerated stress audit, ensures manufacturing process control. The Reliability Testing Lab looks more closely at the user environment and user interface to find ways to improve the reliability of Compaq products in customer environments. This walk-in thermal chamber enables us to test a complete functioning rack of servers under various conditions. We also test and characterize components, such as our keyboards, to ensure the reliability and feel of the user interface across product lines. Compaq builds in protection against hazards in the workplace, such as static discharge that could strike the unit. And we work to minimize the risk of failure due to the repetitive movement of mechanical joints. The reliability testing in this lab helps to ensure that our products will perform as promised through even the harshest conditions. Compaq's environmental testing lab also performs stress tests, but these are designed to ensure a product's ability to survive the full range of stresses it might encounter. These include the various stresses a unit might encounter through the shipping process, mishaps during installation and handling, as well as other hazards at the customer site. Mass storage devices are a critical part of any server system. And because they are so sensitive to mechanical stress, they receive special attention in the environmental lab. Acoustical emissions are becoming increasingly important in the server market. Compaq has installed a hemianechoic sound chamber that enables us to test and certify that our products meet stringent noise emission standards. We can provide certification as required for products that will be sold into European markets, and reducing acoustic emissions improves Compaq's entire server line. Servers must also meet electromagnetic emission standards. Before they can be shipped, all of Compaq's products receive both the FCC approval marking for use in America and the CE marking for international products. The testing for a new product takes place in several specially designed test chambers that are shielded against outside radio frequency noise. This test evaluates how much electrical noise is injected by the system back into its power line and data ports, since that noise might interfere with other devices. Another test checks for immunity of the system against noise coming into it. This can take the form of a static discharge, or noise from another device that comes in through a signal port. A third test is performed in a semi-anechoic chamber that absorbs both incoming ambient noise from outside the chamber and any system noise that might be created inside the chamber. Here, antennas measure the electromagnetic emissions radiated by the system, and engineers analyze the data to ensure that the emissions are within acceptable limits. Finally, a smaller, fully anechoic chamber is used to measure the effect of noise radiated into the product from outside sources. Compaq's Electromagnetic Compatibility Lab is accredited by the National Voluntary Lab Accreditation Program. This accreditation is very stringent and difficult to obtain, but it means we're able to certify our own products for compliance with FCC and other standards. This adds value to Compaq's process because when all goes well, we can test a product one day, certify it the next, and ship it out the following day. When all the testing has been satisfactorily completed and the new design is approved for production, it moves to manufacturing. Here, the sub-assemblies and parts are gathered and organized into kits as part of a cell build concept. Compaq has developed an efficient process for assembling systems. The process includes online instruction for assembly methods and several intermediate quality checks. Compaq manufacturing personnel receive extensive training, and no one is allowed to build a product without being certified on that product. Once the products are assembled, 100% of Compaq's industry standard servers are connected by a network interface to a remote test server and go through a run-in process. The run-in process includes several diagnostic steps that verify the functionality of the components and subassemblies and identify any system interaction issues while providing maximum system stress. The amount of time required for run-in varies by the complexity of the product, but it can be as much as 24 hours. After run-in, 10% of Compaq industry standard servers go through an audit. We randomly select finished units off the line for testing to help ensure that customers will be fully satisfied. Another 1% are selected for a special customer site simulation. Finally, the product is boxed and labeled for shipping to its destination. And And that brings our tour of the birth of a Compaq industry standard server to an end. As we have seen, Compaq's industry standard servers are designed from the ground up with innovative features and scrupulous attention to detail. In-house design and testing help Compaq maintain the highest standards and ensure good operational margins. In summary, the engineering and testing that go into Compaq servers create the high performance and reliability that gives customers an excellent value for their computing dollar. To learn more about Compaq server solutions, visit our website at www.compaq.com.